Yeah, I welcome you back to this class. So, what we have discussed yesterday is all about uplink control information, right? So, the next thing is let us see how do we do the resource mapping. Okay, resource mapping in the uplink transport channel processing. So, as we were discussing the physical uplink control channel and as well as the physical uplink shared channel. Okay, are never transmitted simultaneously from the same user equipment. Okay, hope you understand what I say. There are two uplink channels, right? One is the physical uplink control channel, and second one is the physical uplink shared channel. So, as I said, these two means PUCCH, right? Physical uplink control channel is never transmitted simultaneously with the PUSCH from the same user equipment. Okay, so what I mean to say is the physical uplink control channel is time division multiplexed. Okay, with the physical uplink shared channel from the same user equipment. So because of this is time division multiplexed, so PUCCH cannot be transmitted simultaneously with the PUSCH from the same user equipment. So that is what the reason is. Uh, to retain the single carrier property of the SCFDMA, so this has been done. Okay, the uh, physical uplink control channel can be frequency division multiplexed with the physical uplink shared channel from other user equipments in the same subframe. Okay, so PUCCH is time division multiplexed with the PUSCH. That is why PUCCH cannot be transmitted simultaneously with the PUSCH from the same user equipment. Okay, and this PUCCH can be frequency division multiplexed with the PUSCH so that it is possible to transmit from other user equipments in the same subframe. Okay. Then, if the user equipment has not been assigned any uplink resource for the uplink shared channel transmission, then certain set of uplink resources are assigned for the transmission of the physical uplink control channel. Okay, so the physical uplink control channel uses one resource block in each of the two slots in a subframe. Okay, means it uses one resource block. What I mean to say is PUCCH uses one resource block in each of the two slots in a subframe, right? So to get that, so mathematically we express like this: the number of physical resource blocks used for the physical uplink control channel transmission in slot n, okay, is given by this formula. So m by 2, if m plus ns mod 2 of mod 2 is 0, and if m plus ns mod 2 of mod 2 is equal to 1, then it will be number of resource blocks in the uplink minus 1 minus m by 2. So the parameter m depends on what? PUCCH format. So we have discussed what are the different types of PUCCH format, right? One, 1A, 1B, 2, 2A, and 2B. So accordingly, we have discussed what is the value of M bits and other things, right? So with respect to that, it will be calculating the number of physical resource blocks. So according to this rule, the mapping of physical uplink control channel to physical resource blocks in one subframe, okay, which is shown for different values of M in this figure. I said na, it will be using one physical resource block of the same subframe with the two slots, right? Yeah, this is what the diagram which I can show that how the mapping of this physical resource block for the physical uplink control channel. Okay, so this is a even numbered slot, and this one is a odd numbered slot. Okay, and here it is written the number of physical resource blocks. It starts from 0 to number of resource blocks in the uplink minus 1 up up to that value it can take. Okay, so within one subframe, I said it will take the 2 slots as one resource block. Okay. Yeah. So the physical uplink control channel is transmitted at the bandwidth edge, so which is to provide the contiguous bandwidth in the middle for data transmission, as only localized resource allocation is allowed in the uplink. Okay, so where do we transmit? That is also important. Means as I said, physical uplink control channel is transmitted at the bandwidth edge. So if you consider 1.4 megahertz, you all know in that how much is the guard band and what is the bandwidth available for transmission. In that, the bandwidth edge means near at the end of the bandwidth will be used for the transmission of this PUCCH. Okay, so the frequency hopping between different slots will provide the frequency diversity. So that we have discussed yesterday about frequency hopping, right? Whether it is inter-subframe or intra-subframe frequency hopping happens, right? So PUCCH symbols are mapped to resource elements, not used for the reference signal transmission. Okay. So this is all about the resource mapping with respect to PUCCH and PUSCH. So next is the reference signals in the uplink. Okay, so there are two different types of reference signals are used in the uplink. One is the demodulation reference signal. Okay. Second one is the sounding reference signals. So let us try to understand the purpose and the function of these two reference signals. Okay, and also why we need two reference signals in the uplink. The reason also. The first one is the demodulation reference signal. Okay, this is a demodulation reference signal is transmitted on uplink resources, okay, assigned to the user equipment for coherent demodulation of data and control information at the E node B. So that is the purpose of demodulation reference signal. Okay, I repeat once again. Please be attentive and listen carefully. As I said, the demodulation reference signals transmitted on uplink resources assigned to the user equipment. For what purpose? For coherent demodulation of data and control information at the E node B. Okay, that is the purpose. Okay, hope it is clear. Coherent demodulation of data and control information at the E node B. For that purpose, this demodulation reference signal is used. When do we transmit this? It is transmitted on the uplink resources assigned to the user equipment. Okay, the next is the PUCCH cannot be transmitted simultaneously with the PUSCH, we said, right? So because of that, so there are demodulation reference signals defined for each of them. Means there will be a separate demodulation reference signal for PUCCH and as well as PUSCH, because these two cannot be transmitted simultaneously because this is time division multiplexer, right? So there are demodulation reference signals for PUSCH and demodulation reference signals for the PUCCH. Okay, so in a nutshell, what I wanted to convey is the purpose of demodulation reference signal is for what? Coherent demodulation of data and control information at the E node B. You should be able to understand and take this point into your mind. Okay, this is an important thing. Coherent demodulation of data and control information at the E node B. So that is the purpose of demodulation reference signal. Second one is the sounding reference signals. Okay, so the sounding reference signals are basically the wideband reference signals for the E node B to measure the uplink channel quality information for the uplink resource allocation. Okay, so these are what? These are the wideband reference signals for the E node B to measure what? Uplink channel quality information. Okay, that is CQI. Okay, CQI is our channel quality information, right? So it is used to measure the uplink channel quality information. Okay, and these sounding reference signals are not associated with the transmission of the PUSCH or PUCCH. Okay, so sounding reference signals purpose is what? To measure the uplink channel quality information. For what purpose? For the uplink resource allocation. Okay, then let us see why we need these two reference signals. Okay, the reason is the demodulation reference signal is the first reference signal, right? So is used in uplink are only transmitted on subcarriers assigned to the user equipments. So therefore, it cannot provide a sufficient wideband channel quality information for resource allocation, okay, particularly over the resource blocks that are not allocated to the user equipment. For that purpose, we need a sounding reference signal. Okay. Then the reference signals in the uplink cannot be transmitted at the same time as user data. So user data and control information, right? So these reference signals in the uplink cannot be transmitted at the same time as user data. So because of that, it requires two reference signals. So the uplink reference signals are time division multiplexed with the uplink data on the assigned subcarriers. Means first we send data and then this reference signal, or first reference signal and then data, because of this time division multiplexing. So the power level of the reference signal can be different from that of the data symbol, right? To why the power level of the reference signal has to be different from the data symbol, because they are transmitted over different SCFDMA symbols. Because of that, okay. So the peak to average power ratio is minimized over each of the SCFDMA symbol. So since we are using SCFDMA for the uplink, so that is what the purpose. So this is what the reason why we need two reference signals in the uplink. Yeah, how do we generate that reference signal sequence, right? So the demodulation reference signal and the sounding reference signals are defined as what? Cyclic shift of the same base sequence. Okay, so like similar to like gold sequence and other things, no? In the same way, this reference signal sequence are also generated. Okay, so the generation of the base sequence depends on the reference signal sequence length, so which is defined as like this. This is the sub carrier, okay, resource block, which is equal to m into number of sub carrier resource block. So where the value of m will be less than or equal to the number of resource blocks in the uplink, okay, and greater than 1, where the value of m is the size of the resource block assigned to the user equipment. Okay, so if m is greater than or equal to 3, then the user equipment is assigned 3 resource blocks or more. So the base sequence is based on the prime length of this Z of 2 sequence. Okay, so I think I told about this even for P-sync and S-sync, that is primary synchronized signal, secondary synchronized signal, all are generated by using this Z of 2 sequence. Okay, that are cyclically extended to the desired length. So for m is equal to 1 or m equal to 2, the base sequence will be of this form. It is in the form of exponential. Okay. So multiple reference signals can be created by different shifts of the same base sequence. So here it is told how this Z of sequence means what property of the Z of sequence is used to do that. Okay. So Z of 2 sequence has a property that the cyclic shifted version of same sequence are orthogonal to each other. So that property will be utilized here. So generating reference signals in such a manner can reduce the intercell interference for the reference signal transmission. Okay, so the orthogonality of the reference signals within the same cell is obtained via frequency domain multiplexing. Then the reference signals for each of the user equipments are only carried in resource blocks assigned to that user equipment. So therefore, the reference signal in the uplink is always the user equipment specific. So in case of downlink, it will be cell specific. Okay. In case of uplink, the reference signals are user equipment specific. Yeah. Let us try to understand about the resource mapping of demodulation reference signals. Okay. So the resource mapping of the demodulation reference signal is different for PUSH and as well as PUCCH channels, because I said that this PUCCH and PUSH cannot be transmitted simultaneously, right? So because of that, there will be a separate reference signal for these two channels, right? Hence, the reference signals are inserted in the time domain, so which is to preserve the low PAPR property of the SCFDMA. So the PUSCH, for PUSCH, the demodulation reference signal sequence is mapped to resource elements, the K, comma L. So that is the what we say with the cell. So with L equal to 3 for normal cyclic prefix and L equal to 2 for extended cyclic prefix. So with the increasing order, first in K and then in the slot number. I think I have shown that how this is allocated. This is about the uh, allocation of the reference signal for PUSCH it is. Okay. Hope this is the time frequency grid. Okay. So this is how the resource mapping of demodulation reference signal for PUSCH with normal CP is done. Okay. So this L is time axis and K is the frequency axis. Okay. So it is using fourth slot, that is 0, 1, 2, 3, right? Fourth slot, not fourth slot, fourth OFDM symbol. Sorry. Okay, so this is one slot. Okay, from L equal to 0 to L equal to 6 means 7 OFDM symbols are there. In that, the fourth OFDM symbol is used for allocation of the reference signal for the PUSCH. Okay. Similarly, that repeats. So this is one resource block, right? Slot 1. The next slot also. So 0, 1, 2, third. So this fourth OFDM symbol, okay, is used for assigning the reference signals for the PUSCH. So this is one resource block from L equal to 0 to 6 and another resource block. That is why it is written here assigned resource blocks. In that, the fourth OFDM symbol will be assigned for the what? Reference signals for the PUSCH. Hope you have understood this point. In one particular slot, every fourth OFDM symbol, okay, will be assigned for this reference signal for the PUSCH. Yeah, so I think I discussed about this. What is the PUCCH formatted? 1A, 1B, 2, then 2A, 2B. So means here we are saying just what is the value of these things for normal cyclic prefix and as well as for extended cyclic prefix. Okay, so PUCCH supports 6 different formats and resource mapping to SCFDMA symbols for different formats. What is shown here? Okay. Yeah, this table is with the, means is a set of value for L for normal cyclic prefix and as well as for extended cyclic prefix. Okay, means this is the location of the uh, what demodulation reference signal for different PUCCH formats. Okay, if the PUCCH format is 1A, 1B, it is a normal cyclic prefix, and this is what the location of the demodulation reference signal. It may be 2, 3, or 4th OFDM symbol of the slot. Okay, for extended cyclic prefix, it will be second or third OFDM symbol of the slot. Yeah, so the number of PUCCH demodulation reference symbols are different for different formats, so which we have seen from the table, right? That is related to the number of control symbols for each format. So, for example, one is given for 10 CQA for PMI modulated symbol for PUCCs of format 2, 2A, 2B. So there are two reference symbols in each slot. Okay, I think with respect to this, okay, you want 2A, 2B, 1 and 5, right? So these are the two reference symbols in each slot, what I want to say. So there are a total of 14 symbols that will fill the whole subframe. Okay, so that is for 14 SCFDMA symbols. Similarly, for PUCC format 1, 1A, 1B has few information bits than the PUCC format 2, 2A, 2B. So there are more reference symbols for format 1, 1A, 1B than there are for the 2, 2A, 2B. That is done to improve the channel estimation performance. I think that you understand with respect to this, right? For 1, 1A, 1B, here there are with normal cyclic prefix three symbols, three OFDM symbols for normal cyclic prefix, and for external cyclic prefix, two OFDM symbols are used as reference signals, right? But for 2, 2A, 2B, only two are used. What is here? So due to the resource mapping of PUCCH, the two consecutive slots are at the two edges of the whole bandwidth can be allocated. Okay, this is what is shown here. What I was telling about 2 or 3, right? This is for format 1, 1A, 1B, right? The reference signals for PUCCH format of 1, 1A, 1B. I said it will be occupying 3 time slots, right? I think with respect to this table for 1A, 1B, it will be occupying the OFDM symbol of 2, 3, 4, right? So it is shown here. So this is 0 symbol, first symbol, then 2, 3, 4. So which is highlighted, right? So these three OFDM symbols will be used by the reference signal for the PUCC's format of 1, 1A, 1B. Okay, this is for the slot 1 and this is for the next slot. Okay, so 0 to 6 is one slot, right? The 7 OFDM symbols will be there. Again, for the next slot, so it will be occupying second, third, and fourth OFDM symbol. And rest other things will be occupied by these symbols: hybrid ARQ, acknowledgement, or scheduling request symbols. Okay. Yes, it is very easy to understand also. So try to be attentive because it is not something very complex. Just it is told very clearly which OFDM symbol of a particular slot will be used by what reference signals. Okay, that depends on the format PUCCH, whether it is 1, 1A, 1B, or 2, 2A, 2B. Right, here it is shown for 1, 1A, 1B. I said for 1, 1A, 1B, second, third, and fourth, right? Right, second, third, and fourth OFDM symbols are used by the here. It is 2, 3, 4. Okay, for normal cyclic prefix. 2, 3, 4 OFDM symbols are used for reference signals. Similarly, for format 2, 2A, 2B, as I was told in this table, was what? 1 and 5, right? So that is what is shown here. So this is a 0 symbol in the first symbol, right? First, then second, third, fourth, and fifth. So first and fifth OFDM symbol is used as a reference signal for PUCCH format of for 2, 2A, and 2B. Okay. Similarly, for the second slot, second and fifth. Yeah. So resource mapping of sounding reference signals. So this is the second reference signal in the uplink. Okay. First one, what I said, that is the demodulation reference signal. So what is the purpose of that? Demodulation reference signal. Anyone of you can say? Yes, my dear students. Hope you are all there. The purpose of demodulation reference signal. Hello, anyone of you can say yes. May not be the answer.
Yes, sir.
Yes, can't say anything. Nobody can talk.
Sir.
Hmm. I highlighted no, the purpose of the demodulation reference signal is what? For coherent demodulation of data and control information at the E node B. Right?
Yes, sir.
And then I told about what is the means which OFDM symbol in a particular slot it will occupy these reference signals. That depends on the PUCCH format, right? For 1A, 1B, I said what are the uh, OFDM symbols in a particular slot is occupied, and similarly for 2A, 2B of PUCCH format, what is the OFDM symbol occupied, right? Okay, similar to that, let us try to understand about this resource mapping of the sounding reference signals. So this is the second reference signal in the uplink. The purpose of this sounding reference signal is what? To measure the channel, to measure the uplink channel quality information, right? That is the purpose of this sounding reference signal. And here we talk in terms of two modes. You all know LTE supports FDD and as well as TDD. So with respect to FDD mode, the sounding reference signal is transmitted in the last SCFDMA symbol in the specified subframe. Okay. For transmitting the sounding reference signal, a specific subframe is specified. In that, the last OFDM symbol will be used by this sounding reference signal. That is in FDD mode. In case of TDD mode, the sounding reference signal is transmitted only in configured uplink subframes, or that field is there, right? Uplink PTS field in the special subframe. Okay, so subframes in which the sounding reference signals are transmitted are indicated by the broadcast signaling, and there are 15 different configurations. Okay, for this sounding reference signal, there are 15 different configurations. Yeah. So in frequency domain, the mapping starts from the location K0, which is determined by the system parameters and fills every other subcarrier. So the bandwidth of the sounding reference signal is configured by higher layers and also depends on the system bandwidth. Okay, means if the system bandwidth is 1.4 megahertz, so based on that, it will have certain number of reference signals, sounding reference signals, and for different bandwidth like 5 megahertz, 10 megahertz, 15 or 20 megahertz, so the location and even the number of reference signals also varies. So by allocating every other subcarrier to a user equipment for the sounding reference signal, the system allows two user equipments to use the same resource for sounding. So this is what the beauty of this sounding reference signal. Okay. So by allocating every other subcarrier to a user equipment for the sounding reference signal, the system allows two user equipments to use the same resource for sounding. So the second user equipment uses the subcarriers not used by the first user equipment. So let me show that with the diagram. So this is what I used to say. What is the OFDM symbol occupied by the sounding reference signal, right? So I said it will be occupying the last OFDM symbol. Okay, so that is what is shown with respect to this. And y-axis has frequency starts from k0. So this is the resource mapping of sounding reference signal with the normal cyclic prefix, and it will be different for extended cyclic prefix. Okay, so hope you are getting some idea where what is the location of a sounding reference symbol and demodulation reference signal. That depends on the PUCCS format. Okay. Yeah. So this is all about whatever we have discussed so far is all about the uh, what I said about resource mapping and as well as the uplink reference signals. Okay. So I said basically there are two types of uplink reference signals. One is the demodulation reference signal, and second one is sounding reference signal, right? And where they are located, that depends on the PUCCH format. Okay. So let us try to understand next about the random access channels. So this is one of the uplink channel, right? RACH, which is used. This channel is used for requesting the resource, okay, from the ENB to communicate with the ENB. Okay, so let us try to understand what it is, what it contains, and all. Okay, so this random access channel, I said RACH, right, is the uplink random access procedure is used during the initial access or to re-establish the uplink synchronization. During that time, it is used. Okay. So the random access channel carries random access preambles. So what is that format? This is what is that. So cyclic prefix CP, then sequence. Let us see what is the sequence it carries. Then the guard time. So this is what the format of the random access preamble. Okay. So the random access channel carries this random access preambles. Hope you're understanding what I'm saying. Random access channels, right? What I said, the uplink random access procedure is used during the initial access. Okay, that is the moment you switch on your mobile equipment, so it will search for the channels. Okay, so during that time only, all this pacing, guessing, everything will be synchronized with the particular cell. Okay, wherever you are there. So, with initial access, or if you want to re-establish the uplink synchronization, during that time, this is used. So, what this random access channel carries is it carries the random access preambles. What the random access preamble is? So, it has cyclic prefix, CP, then it has some sequence. Let us see that sequence contains what. Okay, and then the guard time. The CP duration is denoted as T suffix CP, and the sequence length duration is denoted as T suffix SEQ. Okay, that is the sequence length duration. And similarly, the guard time duration will be there. Okay, so already I said this random access preamble consists of cyclic prefix of length TCP and a sequence of length T seq, right? As uplink synchronization, right, may not be established prior to the random access procedure. So the guard time is also needed to account for the round trip propagation delay between the user equipment and the E node B. So for that, the GT is there. Okay. Why this GT is required? So uplink synchronization may not be established, I said, right? So prior to random access procedure. So that is why the guard time is needed to account for the round trip propagation delay between the user equipment and the E node B. So you all may be aware what is this round trip propagation delay. Okay, so it is the time taken uh, for the signal to travel from user equipment to E node B and again back from E node B to user equipment, right? So the value of the cyclic prefix CP and as well as the sequence depends on what? Depends on the cell size and base station implementation. Okay, so the value of the CP cyclic prefix and the sequence length, okay, depends on what? Cell size and the base station implementation. So let us see what are the different formats it supports. So this radio I was telling about random access preamble, right? So it has 5 formats. So there are 5 different preamble formats, right, which is defined in LTE. That is format 0, format 1, format 2 and 3, and format 4. Format 0 to 4, what we can say. So when do we use format 0? When do we use format 1? Then when do we use format 2 and 3? And all we need to understand, right? So format 0 is used for normal cells, and then format 1 is also known as the extended format, and it is used for large cells. Format 2 and 3 is uses repeated preamble sequences to compensate for increased path loss and are used for small cells and as well as large cells. Okay, means format 2 is used for small cell and format 3 is used for large cells. Then format 4 is defined for frame structure type 2 only. Okay, so we have 2 different types of frame structures, right? Type 1, type 2. So type 1 is of FDD type and type 2 is of TDD type, right? Or TDD. So format 4 of this preamble format of radio access channel is used. Okay, so here what is the length of the cyclic prefix and what is the length of the sequence which has been calculated here. Okay, we all know what is the sampling time. So which is given as 1 by 15,000 is the what? Is a subcarrier frequency spacing into 2048 is the highest or maximum value of FFT size it is. So 1 by that 15,000 into 2048 will give you the value of TS. Okay, so for different preamble formats, here it is given what should be the length of the cyclic prefix and what is the length of the sequence, this one. Okay, so for format for preamble format 0, the cyclic prefix length will be what? 3168 into TS. Similarly, the sequence length will be 24576 into TS. So like that it is calculated for different preamble formats. Yeah. So I said this random access preambles, right? It will have cyclic prefix, sequence, and then guard time. So this preambles, right, are generated again from what? Z2 sequences. So even Z2 sequences are used for generating the reference signals also, right? Even that P sync and S sync also. So Z2 sequence plays an important role. I think most of the sequences are generated by using this Z2 sequence. I think you can just explore what it is. I told at the different places what properties of this Z2 sequence are used, and with that they could able to achieve the required goal. Okay. Fine. So the network configures the set of preamble sequence that the user equipment is allowed to use. Said na? So what are the, that depends on the format, right? Because this preamble uses 5 different formats, I said. So depending upon the cell size, so the network will be configuring that. So in each cell, there are 64 available preambles. Okay, so which are generated from one or several root Z2 sequences. Okay, so one in each cell, we say there are 64 available preambles. Okay, so due to this zero cross correlation between different cyclic shifts of the same Z2 sequence, so there is no intra-cell interference from multiple random access attempts using different preambles in the same cell. As I said, there are 64 preambles are available in every cell, right? And which are generated from one or several root Z2 sequences because of their zero cross correlation property with the different cyclic shifts. So there will be no interference between intracell, okay, because of that property. Hope you are able to get, though 64 preamble sequences are there, because of the zero cross correlation and different cyclic shifts, right? So there will be no intra-cell interference among the multiple random access which are using the different preambles in the same cell. Okay. I said the transmission of this random access preambles is restricted to certain time and frequency resources. Okay, means this RACH will not be, means this random access preambles, right, which will be carried by RACH. So it will not be transmitted randomly in every UFDM symbol of every slot. Okay, so certain symbols of certain slots of certain subframes is allocated for this. So the physical random access channel, what we say PRACH, resources within the radio frame are indicated by this PRACH configuration index, so which will be provided by the higher layers. Okay. So for frame structure of type 1 with the preamble format 0 to 4, that is there are 5 different preamble formats, what I said, right? Uh, that is for frame structure type 2. Only for type 2 I said format 4 is used, right? So the preamble format 0 4, there might be multiple random access resources in an uplink subframe, so depending upon that uplink or downlink configuration. Yeah, so in the frequency domain, the random access burst will occupy the bandwidth corresponding to 6 consecutive resource blocks. So 6 consecutive resource block. So each resource block will have 12 subcarriers, right? With a subcarrier spacing of 15 kilohertz. So with that, so 12 into 6 will get 72 subcarriers, okay, in a subframe or a set of consecutive subframes. Hope you are understanding what I'm saying. In the frequency domain, the random access burst will occupy a bandwidth corresponding to what? 6 consecutive resource block. So 6 consecutive resource blocks will be equal to what? 72 subcarriers in a subframe or a set of consecutive subframes. So this is with respect to the subcarrier spacing of 15 kilohertz. Okay, if the subcarrier spacing is different, then the number of subcarriers will differ. Okay, the physical random access channel uses a different subcarrier spacing, okay, than other physical channels. Okay, together with the preamble sequence length, which is denoted as n suffix ZC. Means ZC indicates this is the Z2 sequence, right? So the preamble sequence, which is generated by using this Z2 sequence, that is what is denoted Z n suffix ZC. So the preamble format 0 to 3 have a subcarrier spacing of this much, 1.25 kilohertz, and the sequence length will be of 839, And I hope I told what is this psi, right? Its value is 7. And the preamble format 4 uses a subcarrier spacing of 7.5 kilohertz, and it has a preamble sequence length of 139, and this value is 2. Okay, so the data symbol subcarrier spacing of 15 kilohertz, right, is an integer multiple of this physical random access channel subcarrier spacing, so which is known as delta FRA. That indicates what this is for random access channel. Okay, subcarrier spacing for the random access channel. So this is used to minimize the orthogonality loss in the frequency domain and can also reuse the IFFT or FFT components. That is what the purpose of that. Uh, yeah, yeah. Here with some mathematical relation is given how this random access signal is generated. Okay, as I said, this PRACH will be different from other uplink physical channels, right? The baseband signal generation for this physical random access channel is different from other uplink physical channels. Okay, and here no DFD based precoding is used, and the DFT of this Z sequence is uh, also a Z sequence. Means if I take the DFT of two Z sequence, again I will be getting the Z sequence only. So that is what the meaning of that is. So the continuous time random access signal is defined mathematically like this. So S of t is equal to beta into summation k equal to 0 to the number of subcarriers minus 1, then summation n equal to 0 to what number of subcarriers minus 1 x u of this formula. Okay, just you can refer what it is this. Here it is written. So beta is an amplitude scaling factor for power control, and this one is the youth Z sequence cyclic shift V. Okay, x u of u x suffix u comma v of n is the youth root Z sequence with the cyclic shift V. Okay, and the psi is the fixed offset that is determining the frequency domain location of the random preamble with the physical resource block. Okay, so every term is given. What is each term is? Just have a look. How do we express this random access signal? Okay. Then this is the hybrid ARQ in the uplink. Hope you are aware what is hybrid ARQ. ARQ, at least why we use ARQ. That is automatic repeat request, right? So this ARQ is used for what? Yes, is it possible to say quickly, any one of you? Yes, my dear students, is it possible to say hybrid ARQ? I've given some brief explanation about this in the earlier classes. Hmm? Yes, I think if I say about this hybrid ARQ in the uplink, I can say this module 4 I will be completing. I think let me take up this in the next class, what I feel. Okay. So just have a look because you need to have the background information about this. Right? At least you should know what is ARQ first, and then you will be able to understand hybrid ARQ. Hmm? In brief, I think it has come in module 1. Before adaptive modulation and coding, I discussed in brief. Okay, what is the functionality of this protocol and how it helps here. Okay, so if I spend another 10 minutes, I think I will be able to complete this. So let me take up in the next class only.